Hi guys, in this video we're going to be learning about energy transfers, thermal insulation, and we'll finish with a summary.
Let's talk about the practical side of energy transfers. In any process that we're interested in, energy is transferred both to the useful energy stores and the wasted energy stores. So what we're saying is we start off with some amount of energy that we put into the process, and some of it will go into doing what we want to do, but some of it will be wasted, for example as maybe heat. Now the total energy we know is conserved, that is all of the energy we put into the process is either going to end up being useful or will go into the wasted output energy. Therefore, if we decrease the amount of wasted energy, we will increase the amount of useful output energy. That is assuming we put in the same amount of total energy. Now, as I kind of hinted at a second ago, generally the wasted output energy store tends to be a thermal energy store. So that is, given all of the energy that we start off with putting into the process, some of it will be useful and some of it is usually wasted as heat. As a result of this, we can often minimize losses by adding thermal insulation to our system. Now it turns out that whenever an object gets hot, it will then lose its heat to the surroundings. So here we have a potentially hot object with heat escaping from it. So let's imagine we're putting energy into our house to try to heat it. It would be absolutely useless if the energy we were putting into heating the house was then able to escape, therefore cooling the house back down. So how can we prevent this from happening? Well, first of all, there's things we can do to the walls. For example, thicker walls on a house will have a lower thermal conductivity and will therefore prevent heat from escaping via conduction. Another thing we can do is add a cavity in the wall, that is a gap in the wall, and fill it with air. And this will prevent conduction across the wall because air is an insulator. And another way of saying that would be that air is not a good conductor. Heat cannot pass through a gas via conduction very well at all. Now the problem we might have with having an air gap there is it might allow energy transfer by convection, because that's something that happens with liquids and gases. So then we add an insulator such as foam in the gap to prevent these convection currents from forming.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific GCSE physics and combined science videos, just click on the Snap Revise smiley face. Join me today and let's make physics at GCSE a walk in the park.